Hello and welcome to the Python built-ins lesson. Today the questions we're going to address are: how can I use built-in functions? How can I find out what they do? And what kind of errors occur in programs? Our learning objectives are to explain the purpose of functions, to correctly call built-in Python functions, correctly nest calls to built-in functions, use help to display documentation for built-in functions, and correctly describe situations in which syntax error and name error occur. All right, so functions in Python. Functions are effectively commands that you can run or execute in Python. Already in previous lessons, we've seen a few examples of functions and we've used them, such as print and len. And in the last workshop, we also covered the type command or function. Later in this workshop, we'll demonstrate how to write your own functions and perform specific tasks repeatedly. A function may take 0 or more arguments. An argument is a value passed to a function inside parentheses. So essentially, when you see a function like print or len, what it goes inside the parentheses are called arguments. Len takes exactly one argument because we want to get the length of a thing, like a string. Int, string, and float also take one argument. Print takes 0 or more arguments. If you say print with no arguments, it prints a blank line. So let's see an example of that. And just to note, we always use parentheses when calling a function, even if they're empty. That actually tells Python that there's a function being called. So for example, if I type print with no parentheses, Python's warming up, and it just says print is a function, print. Whereas if I say print with empty parentheses, well, it prints nothing, which is more evident if, as in the example, I say print before, and then I do the print with an empty argument, and then print after before, and then you can clearly see there's a blank line, which is caused by that print with empty parentheses or no arguments. Every function returns something. That means every function called produces some result. If a function doesn't have a useful result to return, it usually returns a special value, none. And you can see here none is capitalized, and I've shown it in the computer like a fixed width font, because that's an explicit value or object in Python that stands in anytime there's no value. Somewhat counterintuitively, print returns none. The print function itself does generate output to the screen. You can see it, but internally, the result of a print to Python is a variable, and that variable ends up with a value of none. And we can see this by, rather than just running a print command the way we typically do, we assign the result of print to a variable called result. So if I say print example, assign that to result, and then print the result of print is, comma, and then the variable result. Whoops, not results. The result of print is none. It's kind of a subtle point, probably not something you'll encounter regularly, but just to make the point that every command does generate some sort of result. So there's some commonly used built-in functions in Python that we haven't covered yet around working with numbers and data. These include things like max, min, and round. So max finds the largest value of 2 or more values. So max needs at least 2 arguments. Min finds the smallest. So again, you need at least 2 arguments. And both work on character strings, as it turns out, as well as numbers. Larger and smaller use this sequence. So 0 to 9, so sort of your logical, numbers when represented as characters are sort of evaluated as numbers for this min-max purpose. And then uppercase A to Z, and then lowercase A to Z. So for example, if we say print max 1, 2, 3, that's an easy one. And then print min character A, lowercase, character A, uppercase, and 0 is a character. The minimum of those is 0. If in that second command I took out and I just compared lower and uppercase A, you can see somewhat counterintuitively, the uppercase A is actually lower in the hierarchy than the lowercase. So 0 to 9 are lower, A to Z are bigger than the numerals, and lowercase A to Z are sort of considered higher or bigger than the uppercase equivalents. You may encounter places where that matters, but usually when you run min and max, you are actually given it just numerals to work with. Some functions may only work with certain combinations of arguments or certain arguments. So for example, if we try and print the output of max 999, or print max 1, note that 1 is an integer, it's not in quotes, and a is a character, we get 2 errors. Well, we get 1 error because it hits the first line, tells us a type error. So we don't actually even get evaluated the result of the second line, because as soon as Python hits that error, it craps out. So let's say max of 999 and 1000 to solve that one. And now you can see it throws an error on the second line because it says greater than is not supported between instances of string and integer. Now you may wonder, what do you mean greater than? Because I don't see it and use a greater than sign. But internally, that max command is applying a greater than test to determine which one is bigger than which. So that's the output. But regardless, it doesn't work. So you'd have to either convert 1 to a character, string, or, well, you can't really convert a to a number. So if you wanted to do that, convert 1 to character string, and now a, as we said before, lowercase letters are considered bigger than numerals when represented as strings or characters. Functions may have default values for some arguments. So the round command will round off a floating point number. If we don't give it how many decimal places we want to round, so if we give it a single argument, which is the number we want to round, like round 3.712, it rounds it to an integer, to a whole number, so it drops all the decimal places. But if we give it a second argument, round 3.712 comma 1, that second argument is the number of decimal places that we want to round to. So we get rounded to 3.7, likewise round it to 2 places, you get 3.71. So some functions have a specific number of arguments that they require, other ones have a variable number, and sometimes 1 or more are required, and then additional ones are optional. So, how do you know before you've used the function? We'll get to that, because there is a way to get help for those. So we've seen some errors, and now we're going to talk a little more explicitly about the kinds of errors that might happen when you're running functions. And quite frankly, when you're coding, you're going to make so many errors. You're going to make, errors maybe more than you do things correctly, especially at first. So it's good to, A, get used to that and comfortable with that and not stress out too much about it. It's just part of the learning process and even part of the normal sort of day-to-day process of coding and data science. But also understand, how do you diagnose and fix those error messages? Okay, so I've provided this erroneous code explicitly. You can probably see what's missing is the closing parentheses on this print function. So when I run it, it says syntax error, unexpected EOF while parsing. And above that, it said file, temp, ipykernel, blah, 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 line 1. What that's telling you is the error is on line 1 of the code, the cell that you just submitted. Internally, each cell in a Jupyter Notebook is treated as a separate file with this sort of temp, garbagey sort of code that Jupyter is using internally. So you don't really have to worry about that, but the line number does help you know within that cell which line to look for. Then you get the output, the input, the line that you typed that had the error, and you see this little caret, this little character in there pointing up. That's pointing to the exact point in the line where Python encountered an error and realized there was a problem. Now it's a syntax error, which means there's a problem with the syntax, with the grammar of the language, how you're framing the language. And the type of syntax error is unexpected EOF while parsing. Parsing means going through your code and trying to interpret it and make sense of what it does. EOF means end of file. In this case, the end of the file is the end of the cell, the end of the line. And it's unexpected because every time you open a parenthesis in Python, it expects you to close the parenthesis. That's required of Python syntax. Anytime you open a parenthesis, you close it later. So it got to the end of the file without finding that closing parenthesis, so unexpected EOF while parsing and trying to figure things out. Now, because it's a syntax error, this is another thing about Python, is when you execute a block of code in a Jupyter Notebook or execute a Python code file, the first thing it does is it looks through your entire code and checks the syntax and figures out if there's problems like this unexpected EOF, missing closed parentheses, other things that are violations of Python syntax. Before it even tries to run the code, it just sort of does this check to see if your grammar is good, essentially. And if it encounters any sort of syntax error, it won't even try and run the code. It'll throw an error right away. Later on, we'll see other kinds of errors. And earlier, we've seen things like type errors in the last lesson, which were errors that were generated when it actually executed the code and figured out that what you were giving it was the wrong type or an incompatible type or something like that. All right, here's another type error. We can try and copy that and run it. Syntax error, kind of same thing, except now it's EOL while scanning string literal. So we used quotes to start a string. This is the string, so it's scanning the string and it hits EOL, end of line. And we hadn't closed the string, we hadn't provided closing quotes. So we fixed that just by the closing quotes. And here, age equals space equals 52, we get invalid syntax. So part of the Python syntax is if you have the assignment operator, the equals, then you need to have a value after that, not another operator. So as soon as it sees an equals, it expects some sort of value, int, float, string, whatever. Getting an equal sign, that's invalid syntax, so it's a syntax error. Now in this next one, we see a runtime error. And again, this is typed out for you, so you can just run it. And what we see, okay, so name error in module, and it shows us the line, the code that we ran, and the line numbers here, slightly different from above where it said line 1. So on line 2, remaining equals 100 minus AEGE. And we have this comment. Remember that anything after a hash mark on a line doesn't get run by Python, it's just a comment. We misspelled age, that's the error. And what it's telling us is name error, AEGE is not defined. So age is defined, AEGE is not defined, and so that helps us figure out, oh, okay, we have to fix that. Naming error, runs, we're totally fine. Okay, so that's just a sort of an overview on when you get errors, how to try and diagnose them. Usually it involves, looking at your code, but those error messages can at least give you a sense of what line and even what position in the line sometimes. And sometimes those error messages may seem a bit confusing at first, but if you focus in even on specific bits of them that you can understand, that's usually enough to help you understand where the error came from and start trying to figure out how to fix it. Okay, as I said before, until you're familiar with a particular function, you may not know how many how many arguments it requires, which of those are optional, what kind of arguments it takes even. So how do you find that out? Well, Python has built-in help, and it's the command or the function help. So if I say help, and then in the parentheses, so the argument that I give to the help function is the name of the command that I want help with. Don't have to put it in quotes, it's not a string, it's a Python command. So if I ask for help on the round function, it tells me built-in function, round, and then it shows me what the arguments are, number and n digits. And in this case, n digits equals none. So that's telling us that by default, if we don't give it a second argument, there's a default value assigned with the equal sign, which is none. Then also it has some explanatory text of what it does. So number is required because it doesn't tell us any default value, but n digits is not required because it's none by default. In Jupyter Notebooks and in CoCalc, there are additional ways to get help. So one is that we can place the cursor near where the function is invoked in a call. So in this case, the function is print, so I'm going to put the cursor there. See, I clicked on it, it's flashing. Hold down Shift and press Tab. And look what popped up down below, introspection. Doc string, just string from a document. Here's our command, print, parentheses, and the different arguments that it takes. So it takes a value, at least one value. The ... after that means it can take any sort of infinite, or probably not realistically infinite, but any largish number of additional values. It'll print them all out as long as you separate them by commas. Sep equals quote space quote. That means that by default, when you do a number of values separated by commas, it'll use a separator of a space in between those. But you could actually change that. So you could say sep equals comma or hyphen or something and change how it separates the things that it's printing out. End equals \n. That's the code for new line. So basically it's saying that at the end of that print command, it's going to go to a new line. So when you run a second print command, that would come on a new line. But that's also an argument that applies by default, but you could change it if you want to. These other ones we won't worry about too much. File is basically where the output gets directed. sys.stdout, system standard output, means basically put it to the screen. In principle, though, you could run the print command and export that output to a file rather than to the screen. So that's way of help getting number one is the help function. Way number two is in a notebook. You can move your cursor next to the command, Shift Tab, that gives it to you. I can close that help with the X there. And then option two is to type the function name in a cell with a question mark, then run the cell. So I could say print question mark, and again, Jupyter pops up this help. The nice thing about doing it this way, rather than running the help command in a cell, is that I can scroll up and down in my notebook and that help stays there, which is sometimes a useful thing to have. Okay, I'm going to close that. And so that's how you get help about functions. Another related topic around help is when you're writing your own code to help yourself in the future and other people reading your code by using comments. So these aren't really sort of how to use a particular function, but they are helpful. So it's sort of included in the section on help. So you can see here, this sentence isn't executed by Python because the line starts with a hash mark. Second line, adjustment equals 0.5, that'll be run, but then as soon as Python hits the hash mark, it doesn't read anything else on the rest of the line. So anything after that hash mark is ignored, it's just a comment for human readers. All right, so that covers the lesson material, and now we move into exercises. So as usual, if you want to pause the video at this point and work through these exercises on your own, then unpause them if you're stuck, you don't understand, or just to get confirmation. You can do it that way. So pause now. Okay, and now I'm going to work through the examples that hopefully you've already worked through. Okay, so the first one is what happens when. Explain in simple terms the order of operations in the following program. When does the addition happen? When does the subtraction happen? When is each function called, etc.? What's the final value of radians? So we start out with radians equals 1.0, and then radians equals max 2.1, 2.0 plus min radians, comma, 1.1 times radians minus 0.5. Yeah, so there's a lot to unpack here. Remember that what Python does with order of operations is it goes from the inside out. So the outermost function that we're running in this command is max, right? And everything's in these parentheses. And Jupyter's helpful in that when you have your cursor next to a parenthesis, it shows up in green. And the corresponding close of that open parenthesis also shows up in green. So it helps you sort of parse out what's contained within that, the arguments to that max function. So the max function contains how many arguments? 2.1, comma, and then there's no other commas. The rest is just one chunk of code that's going to be computed. So we're comparing the max, or finding the max between two different values. One of them is 2.1, one of them is this thing. And what is that thing going to be? Well, we're going to compute the minimum of radians, which is 1.0, and this other thing, which is 1.1 times radians times 1.0 minus 0.05. And even within there, we've got a nested order of operations. And remember that multiplication happens before subtraction. So it's going to compute 1.1 times 1, which is 1.1, minus 0.5 is 0.6. It's going to compare that to radians. So 1, the minimum of 1 and 0.6 is 0.6. It's going to add 2 to the output of that min command. So now we have 2.6. And then finally, max is going to compare 2.1 with the result of all of that, which is 2.6. 2.6 is bigger than 2.1, so the end result is 2.6, as shown in this word solution here. Okay, the next one is spot the difference. Predict what each of the print statements in the program below will print. And then the second question is, does max, len, rich, poor run or produce an error message? If it runs, does the result make any sense? Well, I guess we have to kind of run that while the answer's down there, but we'll run it anyway. So easy string equals ABC in quotes. Let's print the max of easy string. I'm actually just going to run these two lines before we go further and then see what happens. Okay, so the max of easy string is C. That's interesting. Maybe we didn't expect that to happen, but when it gets a string, it actually looks at the individual characters in the string, the max function that is, and finds the maximum character within that string. And remember, ABC, it goes from A to C, so C is considered bigger than A. So the max output there is C, okay? Now we're going to say rich equals gold, poor equals tin, and print out for me the max of rich and poor. So let's run that. So the max of rich and poor is tin. And then finally, let's print out the max of the length of rich and the length of poor. Oops. We get an error because I had a typo. There we go. Okay, so the length of rich is 4, right? G-O-L-D, that's 4 characters. The length of poor is tin, is 3 characters. So the max of the length of those two is 4, the length of rich. Whereas the max of rich and poor is tin. And that's really because T comes later in the alphabet than G. They're both lowercase. And from A to Z, the A is the lowest value and Z is the highest value. Oh, and I see why. Oh, I see. There's actually a typo in my example relative to what was expected there. So what the explanatory text is saying below is that if I ran print max of length of rich and poor, that throws an error because poor is tin, it's a string, and the length of rich is an integer. So what we really want is what I showed you originally, which is the length of the two. Okay. Another way of getting help is what's called APIs, or Application Programming Interface. And so this is essentially the API for a command is the help for the command, as we were seeing it before. But it's good to know the term API and be able to sort of interpret APIs, because as you go on in coding, especially with different packages, it may be useful to look at the API or Google the API rather than using the help inside. So for example, here there's a link to the API for the NumPy command. NumPy is a Python library for doing number stuff, basically, all kinds of math. So there's a function called NumPy mean. If I click on that, it takes me to NumPy mean. But likewise, if I Google API NumPy, what I get is the NumPy reference. And it shows me all the different things for that. If I search for like mean, here I get lots of answers. NumPy.mean is one of them. Click on that, and here's the API for the mean function within NumPy. And it tells you, as you see here, this is kind of equivalent to the help we saw before in terms of what arguments it takes, if they're optional, what their defaults are, and that sort of thing. So you can get help internally in Python, but also Googling some function name and the word API will probably give you some help that's useful from the web. Okay, so to summarize, functions are Python commands that return some sort of result. Commonly used functions that are built into Python are max, min, and round. When I say built in, that means they just exist when you type them when you're running Python. Other commands like that mean command that we just saw in NumPy we'll come to later. You have to actually explicitly import the NumPy package to make it active, so it's not built in. So that's what we mean by built in, is they're just there by default when we open Python. A function can take 0 or more arguments, but it always has to have those parentheses at the beginning. So some functions might only work for a certain number of arguments or certain combinations of arguments, and they may have some that are optional that have default values. Every function returns something. We can fix syntax errors by reading the source code, and runtime errors by tracing the program's execution. So we've looked at, when you get an error, how do you make sense of it? What's your sort of strategy for sort of parsing out that error message and using it to help you fix your code? In the Jupyter Notebook, there's 2 ways to get help. Oh, I see there's a bullet point missing here. Use the built-in function help to get help for a function. Let's just fix that bullet point. And then the Jupyter Notebook has 2 other ways to get help. You can use a question mark followed by the function name or after the function name. Doesn't matter. You can say question mark print or print question mark. And you can also position the cursor over a command name and press the Shift and Tab keys for the help to pop up. And remember, Python reports a syntax error when it can't understand the source code of a program. So it parses it. It doesn't make sense according to Python grammar, and then it doesn't execute the code. Alternatively, it may throw a runtime error if the syntax is okay, but something goes wrong while the program's executing. This brings us to the end of our Python lesson on built-ins. Thanks for watching, and we'll see you next time.